Hi folks, today I bring to you a small project to reuse a board with a VFD driver which have the reference M66004SP. This driver have internal table with the ASCII chars and also have 16 RAM positions. You can define chars, specific chars you need. Okay, in this case, in this code I have done, I use these 16 memory RAM positions to define the bits which allow control the upper symbols. Okay, this is zone here have 24 symbols distributed by three grids, but these three grids at this moment represent only one grid, in this case the grid 11. Okay, you have 10 grids in below position here from 0 to 9, and here is the grid A. In this grid you can fill with the chars from your internal table, or you can also address bit by bit of this matrix, which is the 5 by 7. Have two ports, port 0 and port 1, which you can control and switch on or off with the commands send it to the driver. Okay, I made some changes here in the board to reuse it because I don't know the total schema of these components here, and by this reason I remove a transistor here, a C here, and another C here. Okay, here I also remove a C. Okay, this is a C I remove from the left, this is two C's I remove from there, and this is transistor I remove from there. Here I up these three components. Okay, this is a diode, resistor, and below of the VFD here in this zone also I remove the diode and the two resistors. I do it because the power up of the board is done by the 4 wires in the right side, but I only can determine the 5 volts DC here. Okay, you have blue, the first pin upper is GND, after the orange is the plus 5 volts, the yellow and the green I reuse these two pins to bring the power up of the filament. Okay, in this case I deliver here in these two pins, yellow and green, 5 volts DC with 3 diodes in the serial. Okay, to drop 0.7 volts by diode, which means you have here two filaments about 3.2 volts. Okay, the other side you also have 4 wires, and the first wire up is green, and this green is direct connected to the receiver of infrared. After you have the yellow, brown and white. These 3 pins, yellow, brown and white, is used to receive the 3 pins or 3 signals is necessary to control the VFD. In this case is data and the clock and the strobe. Okay, you only need these 3 pins direct from the Arduino, and you can send the signals to control the VFD. I have done a small code, and this code is running over upper Arduino. I'm using Arduino because some people ask to do it with Arduino. Okay, and you can see the code is running now, and represent here the chars. Test all the VFD, control the 2 ports, pin 1 and 0. Also here you see 16 grids right step by step. I only test 16 because I refer to the position I have right in the RAM of the customer use, but you can use others. Okay, now it's running the test here up 16 symbols and repeat again with the right of all VFD, test the ports and so on. Okay, you can use this code to get your ideas and check how you can adapt to your project. Okay, in this case is the one board with a driver inside, but you can use this driver independent and is only connect direct to the output of your VFD and adapt the code. Okay, the changes I have done to the board allow me to connect directly the less voltage. In this case I'm using less 23 volts here, direct to pin 32 of the driver, and you can see here also the shunts to connect direct to the VFD power filaments. And now if you look to the document of the VFD driver, you find here the information related with the RAM position of memory. Okay, how you can see here, you have one example of the code to write the letter F, and you see here the table of the 5 columns and 7 rows here. Okay, and each address in this matrix bring up segment of your VFD. Okay, you have also here in the document the pinout. Okay, is a 64 pins IC, and for example you can see here in pin 17 and 18 the port 1 and port 0. You have here the signal control. The reset is pull up with a resistor, and here you have a chip selector, also is a inverted signal, the clock and the data. The remaining pins is the segments and the grids. Okay, you have possible to go from the grid 0 to grid 16, and you have until 35 segments, if I don't, yes, 35 segments. Okay, the VSS in this case is the GND, and you can find the negative voltage in the VP pins is pin 32 and so on. Okay, is very easy to use it. This processor or this driver, you only need to connect the chip selector, clock, data, reset to pull up with a resistor, the VP, the GND and the VC. You have here VCC2 and here you have VCC1. This VCC1 and VCC2 is the same. Okay, this is 5 volts DC. Here is less 23 volts and the GND. Okay, here is the table of the matrix, the 5 by 7, and you can see here the 5 columns. Okay, and you have 7 rows. And if you write, for example, the bit 1 of the first column in the first position of the RAM, you will write the symbol external. If you write the second digit 1, you will write the last segment of the signal, and so on, okay? And you can see here the first digits of each byte don't have a symbol assigned, okay? The symbols you use is external, the last symbol of the signal, letter 2, key U, is not connected. After you have the key in the second column, the chant, the dot of the signal, the letter C, and the left antenna. Here you have the coder, NRS, the second segment of the signal, band, letter B. The symbol of the clock, the right speaker, the middle segment of the signal, the tuner, the letter A, the int, the left speaker. Here is the last, not last, before the last signal segment of the signal, the letter 1 or the number 1, and the right antenna, okay? Each position, if we write here digit 1 in the a position you define of the memory, when you send this to the grid 10, 11 in this case, you will make the letters tuner right, okay, and so on, okay. I will let the code in the GitHub, and I expect you can reuse this kind of the drivers with a VFD. Okay, good job.